previous functional demo, I built an estimate for a hydraulic shovel, and I want to show you the underlying database that made that possible. First, a little background. I've worked in the industry for over 30 years, and I've been building maintenance plans since 1983. That's put me in direct contact with over 1,000 in-service machines, and I've worked with the information and data that's associated with them. One of the problems with that, though, is that every site, every customer looks at that information a different way and structures it according to their own parameters. Um, and so that can make it difficult to put it all into one place in one format. So about 10 years ago, I decided to create a standardized format for each type of surface machine. And as part of that, I decided to build in the contextualization that you see in HME Benchmark and that I'd observed over the years at different sites around the globe. So let's have a look at the database now. I think the first thing you'll see is that this is a very standard type activity-based list of tasks that you'd find for a hydraulic shovel. All the different items have a description, a cost, an interval, man hours, a downtime associated with them. And let's just go down the list to see kind of the scale of this. You'll see these are just the first 100 items on the list. I use 141 items to describe a standard maintenance plan for a hydraulic shovel. Go up a little bit. Let's just stop at the GET section here to give you an idea of how much detail there is in this data set. You can see that it goes right down to the tooth changes. The rest of the data set has a similar amount of detail contained within it. Looking at the data in terms of structure, again, you'll see a number of degrees of freedom, things like system, category, work type. These degrees of freedom, when they're combined with the variables that you set in the application, that's what provides the contextualization. Those two things in combination drive changes to things like component lives, man hours, costs. For example, if you select different material, that will directly impact the wear lives of the components that are described as wear items. If you select an inexperienced work crew, well, that'll have a direct impact on all of the repair times for that maintenance plan. The different elevation or climate, those will impact specific components contained within the data set. If we scroll across the calculation engine here, you can see where the events are counted and the different categories of costs, man hours, and downtime are summed, and they're, of course, subsequently reported back to the application in the various tables that you were working with there. Similar arrays exist for each type of machine, so rope shovel has its own unique array of activities, as do electric haul trucks versus mechanical haul trucks, dozers, graders. They've each got their own standard maintenance plan. And of course, within those standards, there is a separate data set for each class of machine or each size of machine that belongs to that category. In all, there are about 250,000 data points in this database, and that's what supports HME benchmark functionality. To summarize, I think there are three important things about HME benchmarks. The first is these estimates are derived from a vast activity-based database. Secondly, That database is probably the most accurate of its kind, and that's because it's based on direct interaction with over 1,000 in-service machines, and it's based on over 30 years of field experience. Finally, you can appreciate just how much work this represents, and as a result, how much value that it delivers to the end user. Thank you very much.